Since an American refinery exists largely to produce gasoline, the coker takes very heavy material that couldn't vaporize in the vacuum tower and essentially cooks it in an operation to boil out any possible gasoline-grade material that's left. What remains after that cooking operation is pure carbon or coke, similar to charcoal. Fundamentally, a coker consists of coke drums and a coker fractionator. Fresh feed enters the coker fractionator a few trays from the bottom of the tower, quickly quenching hot vapors from the coke drums that enter at the bottom of the tower. This contact also causes lighter material in the feed to vaporize. Liquid material from the very bottom of the tower is pumped into the coker furnace, where it is partially vaporized and enters the coke drum currently in service. Steam usually is added to the coker furnace tubes to prevent coke formation. Unvaporized liquid settles in the coke drum, and the combined effect of hot temperatures and retention time causes the formation of coke. Vapor from the coke drum returns to the bottom of the fractionator. Two coke drums are used in the process, alternating duties roughly every 12 hours. One is in process service, receiving the furnace vapor liquid effluent, while operators are removing coke from the other drum. When the coke drum in service has been filled near to the top of the drum, the furnace effluent is switched over to the empty drum. Meanwhile, the filled drum is isolated, steamed to remove any remaining hydrocarbons, and cooled by filling it with water. Then the heads are unbolted, the drum is drained, and the process of removing the coke begins. Decoking the drum is normally accomplished hydraulically using high-pressure water jets. The coke then falls into rail cars sitting under the coke drum. After all the coke has been removed, the coke drum heads are rebolted and readied for the next service. The coker fractionator is similar to other oil fractionators, though somewhat simpler. It normally has one gas oil draw near the bottom of the tower, a pump around, and an associated side stream stripper. Overhead gas from the fractionator is cooled in fin fan and cooling waters exchangers at the top of the tower. A portion of condensed liquid is returned to the tower as reflux, while the remainder is sent along with the overhead gas stream to a gas plant to be further processed. Sometimes this gas plant is a standalone gas plant associated only with the coker, or can be another existing gas plant within the refinery itself. Due to its poor octane value, coker naphtha must be further processed in the reformer to upgrade its octane value in order to be blended into the gasoline pool.